Welcome to System DR, technical deep dive on microservices versus monoliths, visual decision guide. Welcome to our deep dive into one of the most pivotal decisions in software development, choosing between monolithic and microservices architectures. As our architectural choice strategic business decision diagram illustrates, this isn't just a technical preference. It's a strategic business move impacting everything from team structure to operational costs. The optimal path, as shown in our optimal choice deeply context-dependent visual, is rarely black and white. It evolves with your product, your team, and your business needs. Today, we'll provide a visual framework to help you navigate this complex landscape. At its core, application architecture, component structure, and interaction defines how an application's components are organized, how they communicate, and how they're deployed. The two dominant paradigms, monoliths and microservices, represent fundamentally different philosophies. Let's start with the monolith. In our monolith architecture, single unified codebase diagram, you see a single, unified codebase where all functional components are tightly coupled and deployed together. Think of it as a single, large building housing all departments and services. It's characterized by a single codebase, often a shared database, and tight coupling between components. This means, as highlighted in the monolith single deployment unit visual, the entire application is compiled and deployed as one artifact. When does this traditional approach shine? It's ideal for small startup teams, lean canvas. With limited resources and a need for speed, a monolith minimizes initial overhead. Developers can quickly grasp the entire codebase, focusing on product-market fit rather than distributed systems complexity. We often see this with early-stage SaaS startups, needing to get an MVP out quickly. The monolith also excels for monolith ideal, simple, stable applications. If your application has a clear, well-understood, and relatively stable domain where the business logic isn't expected to change drastically, the overhead of microservices is simply unjustifiable. Examples include simple CRUD applications or specialized internal reporting tools. Now, let's shift to microservices. Our microservices-independent loosely coupled services diagram shows an application composed of small, independent services, each running in its own process. Imagine a city where each building has a specific purpose, communicating via well-defined roads and public transport. Each service focuses on a single business capability, like an order service or a user service. Communication between these services, as depicted in microservices' lightweight API communication, typically happens via lightweight mechanisms like APIs or message queues. This promotes loose coupling and allows for independent deployment and scaling. Services often own their data, preventing shared database bottlenecks and promoting autonomy. Microservices are justified for large, complex domains, breaking unwieldy applications into manageable pieces. They align perfectly with large or distributed teams, allowing autonomous squads to own distinct parts of the system. This approach also shines for high scalability and availability needs, as individual services can scale independently, saving resources and isolating faults. Furthermore, microservices enable polyglot persistence and programming, allowing teams to choose the best technology stack for each service. This is crucial for continuous delivery, enabling very frequent independent deployments and accelerating time to market. Now, for systems with stringent resilience requirements, microservices offer superior fault isolation, preventing cascading failures. The decision guide involves weighing several key dimensions. Consider your team size and structure. Small, cohesive teams often thrive with monoliths, while larger, distributed teams benefit from microservices. Application complexity and domain volatility also play a role. Simpler, stable domains suit monoliths, while complex, rapidly evolving ones favor microservices. Scalability and performance needs are critical. Granular scaling is a microservices strength, whereas uniform scaling can be handled by a monolith. Resilience and fault isolation are another dimension. Microservices offer isolated failures, while a monolith presents a single point of failure. Deployment frequency and time to market also differ, with microservices enabling faster, independent deployments, accelerating time to market. Finally, think about technology heterogeneity. Microservices allow diverse tech stacks, but a monolith simplifies management with a single stack. The operational overhead and data management complexity are significantly higher for microservices, a premium paid for their benefits. Architectures are not static. Hybrid approaches and evolutionary paths are common. A modular monolith is often a recommended starting point. Structuring your monolith with strong internal boundaries. When a monolith becomes unwieldy, the strangler pattern allows you to gradually replace old functionality with new microservices, slowly strangling the old system. The backend for front-end pattern uses dedicated services for specific client types, simplifying client-side development. Signs that a monolith needs decomposition include slow build times, difficulty adding features, scaling bottlenecks, or team contention in the codebase. However, microservices also have pitfalls, like the distributed monolith, where services are still tightly coupled, or over-decomposition, leading to too many tiny services and overwhelming operational complexity. Debugging, data consistency, and security are also significantly more challenging in distributed systems. In conclusion, there's no universal best architecture. The choice is an art, not a science, requiring a deep understanding of your specific context, future aspirations, and your current capabilities. For most projects, especially in their early stages, a well-designed modular monolith is the safest and most productive starting point. It allows teams to focus on delivering business value and understanding the domain. Listen to your system's pain points. Evaluate your team, application complexity, business needs, and budget. Be prepared to evolve your architecture strategically, only decomposing into microservices when the benefits clearly outweigh the added complexity. By carefully weighing these trade-offs and understanding the practical implications, you can make an informed architectural decision that truly empowers your development efforts and supports your business goals.